All right, so we had to stop early due to an assembly. So this is Geometry Review Part 3, starting from question number 16 for test covering lessons 1 through 35. So I think this is 16, I think, something along those lines. So this is another two-column proof question. So far you're up to about 3 of these. And it wants you to prove, it's going to show you a rectangle. Looks something like this: D, E, F, G. Let's see, it's going to talk about, we're going to have angle 1 and angle 2, something that looks like that. It's going to tell you that, let's see, in our case, DE is congruent to FG. So I could draw this here and here. It'll state that as a given. And then it's going to say that angle 1 is congruent to angle 2. What we want to prove is that angle 1 and angle 2 are right angles. So the missing parts in here, what it's going to do is it's really going to give you everything that you need. Essentially what it's going to do is it's going to set up a two-column proof where my statements and my reasons are all given. Everything all the way through is all there. Everything on my reason side is all there. What you're being asked to do is convert from that two-column proof into a paragraph proof. Now, the thing about it is that for the most part, all the information is there except a few missing pieces. So they may have, statement 1, but me missing reason 1. They may have, let's see, statement 2 and reason 2. Okay, we've got our statement in here, got our statement here, but our reason is missing, in which case we're going to look right here for reason and put that in there. You'll just have some blank spots, so you need to follow the statement, plug in a reason, or find a reason and plug in the statement. It's not really terribly difficult. It's just being able to read and fill in the blank with the matching pieces. So it's more matching than anything else. So that's number 16. 17. Let's take a look at 17. Okay, 17 is a good question. 17, let's see, we want you to find the perimeter of a square inside of a square. All right, so let's say we know this is a square. In here, we've got something looks like this. Okay, let me see. They're going to state something along the lines of like that this whole side is 10 and this whole side is 10. This is D, E, F, and G. Okay, the question is, what is the perimeter and the area of the square? All right, well, these parts here are congruent segments. These parts here are congruent segments, which means that's giving me a 45, 45, 90, where this is 5 and this is 5. Okay, so using the Pythagorean theorem, 5 squared plus 5 squared equals c squared, right? I'm getting 25 plus 25 equals c squared. I'm getting 50 equals c squared. I'm getting square root of 50. I can break 50 into primes into 5 and 10, and 2 and 5, which is giving me 5 radical 2. So I know that this is 5 radical 2. And that should be the case for all of these around here. Okay, 5 radical 2. So my perimeter is 5 radical 2 times 4. So perimeter equals 20 radical 2. Area is 5 radical 2 times 5 radical 2. Okay, 5 times 5 is 25. Radical 2 times radical 2 is 4. which gives me an area of 100 units squared. So that's how you find the perimeter and the area of this figure here on number 17 of your geometry. You need anything else, Jackman? Okay, all right. All right, number 18. Number 18. Okay, it's going to talk to you about a cake. It's going to tell you, all right, so we're going to look at that cake from a bird's eye view. It's going to tell you what the radius of that cake is. Granted, it's not going to actually draw you a picture of any of this, I don't believe. Let's say that the radius of the cake, it's a ginormous cake. Radius of it is 24. Let's see. And we want to cut a single slice out of it that is, let's say, 50 degrees. Okay? We want to know what the area of the top portion, how much frosting am I getting? So we're going to use pi r squared, because that's my area formula, equals measure in degrees over 360. Convert all this to something I can work with, 3.14 times 24 squared times 50 over 360, and that's what I want to work out. Okay, and that's all you have to do with that question. Okay, pi times radius squared times measure over 360. Number 19. Okay, 19. Okay, talks about the median of a triangle. The distance from the vertex to the centroid is, let's see, give me a second here. All right, let me kind of start this question over. They're going to tell you about the median of a triangle and the distance from the vertex to the centroid, and they'll give you a length. They want to know what the length of the entire median is. So if you're looking at something like this, right, a median is where I have a point that's midpoint of a side, and it goes back to the opposite vertex. Now, if we do, 3 of those, right, then what we get is a middle that is a centroid. And so what we're saying here is, let's say that our red line has a length of, well, we want to find the whole length of it. That's what we're questioning. It's what's the length of the median. But if we know the distance from the vertex to the centroid is, let's say, we know that this distance of it is 10, right? What we should know about the distance from the vertex to the centroid is that it's 10/3 of the whole length. So vertex, okay, to centroid is 2/3 of the median. Okay, so what we know here is that 10 equals 2/3 of x. Okay, it's 2/3 of x. So is being my equal sign, of being my multiplication. If I want to undo 2/3, I can't divide by 2/3, but I can multiply by 3/2. So in this case, I would get 30 over 2, so 15 would be the length of the whole segment. Okay, 10 is 2/3 of 15. Okay, so something similar to that. That would be my work. Now, they're not going to draw you a picture. They're just going to give you that information in a sentence format. Okay, finally, question 20. Question number 20. All right, it's going to give you a parallelogram. Okay, let's call it parallelogram HIJK. Okay, HIJK. They say in parallelogram, let's say angle H. Let's say angle H in this parallelogram measures 33 degrees. Okay. Then we want to know the measure of angle K. What is K? Okay, well the first thing you need to do is you need to draw HIJ. JK. Now, all we know is it's a parallelogram, so I'm going to draw it slanted so I don't assume anything. They say H is 33 degrees. Now, obviously, I've put it in an obtuse position, but it's not obtuse. But we're looking for this angle right here. What I need to remember about parallelograms is consecutive angles like H and K are supplementary. So if I take 180 and I subtract 33 from it, right? Let's see, 7, it's 4, 147 degrees is angle K. And that's my answer. Okay, but I need to remember my properties of parallelograms in order to show my work, in order to get this question right. That should be the conclusion of our review videos. Sorry it came into 3 parts this time. That's kind of how it goes.